Next step in our process, after we've applied penetrant, we've allowed it to dwell, and then we've washed it off. We have our type 1 or 2, and then our method A, B, C, or D. Now we need to develop the indications, or develop, and what we're essentially doing is drawing any penetrant that's where capillary action has caused penetrant to go into a crack or a flaw. Now we're going to use the developer to pull that back out. We're going to wick it back out using what's called blotting action. And so now the penetrant's going to travel back out of the crack and into the developer, and then it'll be visible at the surface again. For our fluorescent dyes, part of what it does is it spreads it out a little bit. Remember, these cracks we're looking for are very, very fine, too narrow to see with the naked eye. And so in theory, if we pulled the penetrant out and it didn't spread at all, the indication would be very, very skinny and hard to see with the naked eye. So we're going to, the developer is going to not just pull that penetrant out of the crack, but kind of spread it a little bit to make the indication more visible or larger. Some some developers create a white background to view the penetrant against to increase contrast. So when we're in lab, the developer you use with the spray cans, which is going to leave a white coating on the parts that we're looking at. You're also going to use dry powder developer. That, however, does not leave any kind of a background. It's not made to do that. And then what we have to do is we apply this developer, and then in order to give it time for that blotting action to take place, we're going to give it developing time, or sometimes it's also called a second dwell time. So the development time, again, is also typically 10 minutes. But it can be longer. In some cases, it can be up to 1 or 2 hours if need be. However, most of the time, you're going to be able to see an indication within 10 minutes to 30 minutes at the longest. The big thing with any of these, whether it's the penetrant or the developer, you don't want to leave it on so long that things dry, or that they dry or harden on the part or in the cracks, because they can actually clog the cracks, the indications. I talked about the turbine cases that we did inspection on, and there were some cases where we would measure cracks, and the turbine case would be serviceable, so the airplane would go out and fly. Someone would perform it, and then the next time, this would get done every so often, about every 2 months or so. The next time the aircraft came in and needed it done, they would actually find the crack had shrunk, or the indication from the crack had shrunk. And what happened there is it wasn't properly cleaned, or it had been left on too long, and either the penetrant or the developer had dried in the crack and had clogged a portion of it, and so now you didn't get as long of an indication. So you got to be careful that you want to balance a good developing time, a good dwell time, so that you can see your indication, but at the same time, you don't want to leave it on so long that it dries and can potentially clog the indication, where if it was done again, redone, or done a second time, it wouldn't show up. So developer comes in 6 what are known as forms. Okay, so you remember, you have your type is whether the dye is color contrast or fluorescent. You have your method, which is the rinsing method, so water, solvent, or post-emulsifiable. And then finally, for developer, we have 6 forms that are shown here. So form A is a dry powder. We'll use that in class, in lab. Form B is water soluble. Form C is water suspendable. Form D and Form E are related. They used to actually be the same, but they've been separated at some point. Where Form D is a non-aqueous, so both Form D and E are non-aqueous developers. Basically, that means they're solvent type, solvent based in a spray can, and they can then if you're using a non-aqueous spray can type developer with a type 1 fluorescent penetrant, then it's referred to as Form D. If you have a non-aqueous solvent-based developer that's used with type 2 visible dye, that'll be Form E. And in our case, when you're in lab, the system we have, the system of liquid penetrant that we have, the spray cans that we're going to use, our developer is a dual form. It's Form D and Form E. We'll actually use the same developer with our type 1 fluorescent penetrant as well as with our type 2 visible dye penetrant. So when you're using it with type 1, you would refer to it as Form D. When you're using it with type 2 visible dye, you would refer to it as Form E. And then finally, there's Form F, which are special applications, and I'll talk about what some of those are. So a little more detail on this. So Form A, dry powder, is one of the developers you'll be using in lab, and it's used with all type 1 methods. So this is a very common form of developer that you see. It's probably one of the least user-friendly because you have to, it is a dust, it's a dry powder dust, and you have to be very careful to make sure you evenly dust the entire part. And part of that is it doesn't stay on the surface of the part. It doesn't create a white background or anything like that. But what happens is it's little, the powder is a carrier. And each little speck or each little particle of powder is actually coated with developer, kind of they have a coating on them. And so as you dust the dry powder over a part, it leaves behind that developer. Okay, it kind of rubs off of the individual particles and leaves and sticks to the surface of whatever it is you're testing. And particularly that developer that comes off, it really only sticks in areas where the penetrant is present. That penetrant coming back out, that has to be blotted out of the cracks or crevices, will, it's a wet, there's a wet line there or a wet spot there. And so this penetrant that's being carried by this dust will stick to that wet area. So you can't see necessarily where you've placed it on the part. So you got to be careful to completely and evenly dust it. The nice part is it's easy to handle, relatively easy and handle to store because it's a dry powder. It's not going to leak or spill. You just do want to be careful not to kick it up in the air, and if it does get airborne, you don't want to be breathing it. And then the final part is it's one of the least expensive forms of developer. And so, this is often used in high volume setups where cost can become a factor. Form B developer, the next one, is what's called water soluble. And so in this case, it's one that is dissolved. It comes as like a powder, but you dissolve it in water. And it can be used with all penetrants except method A. So you can't use it with water wash penetrant. The problem is that being a water-based developer, if you use it with, remember, method A, you will potentially wash it off or it won't stick to the part. So again, water soluble, it's going to come as a powder. You mix it with water. The big key here is once it's mixed, it becomes dissolved in the water. And so there's no further agitation required. But again, because it's water-based, it can't be used with method A penetrants because you could potentially rinse the penetrant off or rinse the penetrant out while you're applying the developer. And this is the last part that we have here is it's water-based. Because it is water-based, you have to be careful that you don't get bacteria or other contaminants growing in it if you keep a bath of this around for a period of time. And then with any part, any kind of moisture can potentially pose corrosion issues, especially with magnesium parts or where you have different metals in contact with each other. Our next one is Form C developer. And Form C now it's another water-based developer, but in this case, it's what's called water suspendable. And so this one is, rather than, it's again a powder, but when you mix it with water, it doesn't actually dissolve. The particles just kind of float around in the water. And so it has to be, you have to keep it agitated. It's almost like, it's very similar to like the magnetic particle bath, where, in that case, to keep things from settling to the bottom, we have a pump running that keeps it agitated. And so water suspendable has to be agitated in the same way. It can be used with all penetrants because you don't have to, it's a very quick, you don't leave the water on the part very long. So with the water, it's doing this, there we go. With the water soluble Form B, we have to put it on, we have to put the water on the part and we have to let it sit there for a bit and then slowly dry, leaving behind the developer. With water suspendable, we dip the part, pull it back out, and that leaves, those particles kind of stick to the part as we do. So it can be used with that method A penetrant. In this case, it's very rapid developing. You pull the part out, the particles stick to the part, and then we put it in a dryer, but the water doesn't necessarily have to evaporate. We have the particles there. And so no drying is necessarily required before we use this developer. Whereas others, when we use like dry powder developer, Form A, we have to pre-dry the part before we can apply the developer. Just like with Form B, it's water-based. It can pose a bacteria and corrosion problems. And we have to make sure, in this case, we have to also make sure water evaporation doesn't occur, which could throw our concentration off. And so there's some things that got to be measured and kept track of as we use this. I got people in the chat box I'm trying to let know. The next two, this is where I said developers Form D and E are both non-aqueous solvent based. And in our case, the non-aqueous solvent based, our Form D and our Form E developer are actually the same developer. It just is, it's going to depend on which penetrant type we're working with. So they can be used with all types and all methods of penetrant. So you'll see these all over the place. But type D, when we use it with a type 1 penetrant, it's going to be referred to as type D, Form D developer. And if we use it with a type 2 visible penetrant, then it's going to be referred to as a Form E developer. Now there are cases, in our case, our developer is a dual form. Okay, but there are dedicated Form D and Form E developers as well. We just use the one in our lab that can do both, but there are dedicated ones. So just kind of keep that in mind. Some of them can be used for both, on both type 1 and type 2, and be a Form D or a Form E. Others are only usable with a single type, and so then in that case, they would be a dedicated Form D or Form E. These are the most sensitive of any of the developers. However, they're the easiest to perform improperly. And that's because being solvent-based, a solvent by its nature will dissolve lipids or oils. And so you can see where this, if you over apply it, the solvent that carries the actual developer. So it's a solvent with developer dissolved in it. And when we spray it on, the solvent evaporates, leaving behind the developer. If we over apply it, that solvent, before it has a chance to evaporate, can actually work its way into the cracks and crevices where the dye has remained behind. And it can dissolve it and break it down. So, or even wash it out. Again, it's coming from a spray can. You could even potentially spray it out with the pressure from the spray can. So it's applied by spraying the part. It's available almost exclusively in aerosol form, and it's used for portable methods. But that doesn't mean it's isolated to that. You can use it in a bench setting if you prefer. The last form of developer is what's known as Form F, and this is what are called special applications. So these are used in special cases. One of the most common types of this is what are developers that are plastic or lacquer based. They're a polymer or a lacquer base, and what that does is after you spray it on, it actually dries. It'll dry in place, so it can create a permanent record of the inspection that you've done. So the dye, it almost is like it's almost like a spray paint that, and while it's drying, it draws the penetrant up out of the cracks, crevices, or discontinuities that stains or colors an area of where you've sprayed the developer. And then it dries that way and leaves a permanent indication. And so what these are is they're going to be non-removable, is what you'll see. Now it also is going to seal that crack, so it's not like you can perform other methods down the road. So again, these are special applications. I haven't personally used them or seen them necessarily used in aerospace much, but they do exist out there. I know they're used in civil inspection, bridges and that kind of thing, if they need to mark a spot to come back and basically perform repairs and that kind of thing. So when you're performing liquid penetrant inspection, whether it's your report that's going to be for lab, or if you go work somewhere where you actually perform this as part of your job function, you're going to have to specify all of these different kind of defining names for each of the different steps. So first off, you'll have to write down, is it a type 1 or a type 2 penetrant? Did you perform visible penetrant, or did you perform fluorescent penetrant? Then you'll want to record your sensitivity level. If you're doing type 1 fluorescent, you'll need to record your sensitivity level, 1/2, 1, 2, 3, or 4. If you're doing type 2, that's pretty easy because again, that only comes in level 1. You'll want to specify your method of wash, whether it's method A, water washable, method B, post-emulsifiable lipophilic, method C, solvent removable, or method D, post-emulsifiable hydrophilic. And then finally, you're going to want to record your developer form. And again, form A, did you use a dry powder developer, or did you use a water soluble or a water suspendable developer, forms B and C? Or if you used a non-aqueous solvent, if you used non-aqueous solvent developer with type 1, that's going to be form D. If you use non-aqueous solvent with type 2, that's going to be form E. Or again, if it's one of those special applications where it's going to mark, then you would use form F, and there's some more description that you would put in with that if you ever get into that kind of a thing. So I showed this slide earlier. I talked about what the steps were. We need to clean the part, and then we need to apply the penetrant, allow it to dwell, remove the penetrant with a rinse, apply the developer, allow it to dwell or develop, and then finally inspect. And so looking at each of these steps in detail, here's what we're going to have. So when we pre-clean the part, Again, these are chemicals. We don't want anything to react with them. And so we're going to remove all dirt, oil, grease, gasket material, etc. We've got to have a clean area where we can see what we're working with. Okay. The next thing we've got to do is if there's paint, we can't have paint in these areas. This doesn't work on painted surfaces. In fact, I have you do one of the labs you do, or one of the experiments you do during the lab is on a painted part just to see what happens. And then we pre-clean. We need to use water, detergents, chemicals, vapor, steam, or other cleaning agents in order to do this. You can see these are all chemical or heat or liquid cleaning. But again, in the first part, I mentioned that we can't use mechanical methods such as blasting, wire wheel scraping, or sanding because that can actually peen closed or squeeze shut these very fine cracks, and that can result in a hidden indication. It would prevent our indication from showing, or it would prevent the penetrant from making its way into a crack or crevice. Once our part is clean, then we're going to apply the penetrant. So if you're using a liquid penetrant, so if you're using something that is in a bath or a tub, you can dip or spray or brush it. You just want to make sure the penetrant gets on the whole part. If you're using aerosol cans, you can spray around the whole part. However, you don't have to spray it directly from the aerosol can. If it makes more sense, if you're in an area where when we would do this on airplanes where we were concerned about overspray for the aerosol, we were doing it on the aircraft, so we needed a portable solution. As we would actually spray the type 1 penetrant into like a little paint cup, and then we would use a brush or a foam brush or whatnot to spread it on the part and spread it over the part. And you just have to make sure you fully coat it and that you kind of have enough of a coating on that it will have time to stay liquid in the areas where you want it to potentially get drawn into the areas of indication. And so that's that dwell time. You want to leave it on there for 10 to 30 minutes, but being very careful to never let it fully dry. You don't want it to dry on the part. Now, it doesn't dry very quickly because it is kind of an oil base. However, the stuff that comes out of spray cans is a little bit more prone to drying out somewhat quickly. So just be aware of that. After our penetrant's been allowed to dwell, and hopefully if there are any cracks or crevices that we want to get an indication for, that capillary action has pulled it in, then we're going to start doing our removal process. And this is going to be different depending on what method you do. So we'll start with method A. So remember, method A, penetrants that are method A use a water wash system. And so the water wash, any method A penetrant has a built-in emulsifier, so we don't have to do an emulsification step. And so we're going to use water and we're going to apply it with what's called a coarse flow, and that's we aren't going to use like a shower head type nozzle with a bunch of little sprays. We want fairly low pressure, just kind of what you would get out of like a garden hose or a rubber hose. But again, very low pressure because the penetrant does have a built-in emulsifier. If you have too much pressure, you can rinse the dye back out of any cracks or areas that you're hoping to get an indication. So you got to be careful not to over rinse and that you don't apply it too fast. Water, the water should be roughly room temperature. Anywhere from about 50 to 100 degrees is acceptable. Just know the higher the temperature, the easier it is to overwash. However, at lower temperatures, it's more prone to underwash, and underwash in some cases can be as bad as overwash. If you underwash the penetrant, when you go and do the developing step, you'll end up with a bunch of extra penetrant on the surface, and that could potentially hide relevant indications. So it's kind of a balance of, of temperature of water, how much you rinse, where you want to remove the penetrant from the surface, but not rinse it out of areas of interest. And then after we've removed all the water from the surface, then we need to dry the part after washing most of the time. Now, if you're going to be using, in our case, we'll be using the uh, we'll be using Form A dry powder developer. The part has to be dry. If you are using Form B or Form C, a water soluble, water suspendable, you don't necessarily have to dry the part first. These are in that case, you've already got water on it. But again, you'll be doing that mainly with Form C water suspendable. But for anything that's either dry powder or solvent-based, developers, Form D and Form E, they also do not get along well with water. So we got to make sure the surface of the part is dry. So we're going to put it in an oven roughly 150 to 200 degrees. Our oven, I keep it roughly 160 degrees. And you're just going to put it in there long enough to dry the surface, to get any residual water off. You don't want to bake the penetrant into any of the cracks or crevices. Okay, so that's method A. If we're using method B or D, the emulsifiable versions, post-emulsifiable, whether it's lipophilic or hydrophilic, we're going to start with, you're going to have to emulsify the penetrant that's on the surface. And the definition of emulsify is we're mixing together two liquids that don't naturally mix into a suspension. So if you think about if you think about like oil and water, probably many of you have seen oil and water. Oil floats on top of water. When you emulsify it, you add a third chemical that allows it kind of allows the water to pull away or pull apart the oil. It doesn't actually dissolve, but it becomes a suspension where it can pull it away. And so the emulsifiable here is they're going to use the chemical action. The emulsifier provides a chemical action, and then running water over the emulsified dye. So you apply emulsifier to the surface, the dye that's on the surface, the penetrant that's on the surface, and then you run water over it to rinse it away. So you can see it works very similar to A, where the emulsifier is built in, is we're going to use water to rinse or to remove that penetrant, that excess penetrant from the surface. This was originally designed to reduce the possibility of overwash, but just understand if you're using method B, which is post-emulsifiable lipophilic, it's oil attracting. That will be more likely to cause an overwash because it bonds very tightly and almost acts as a solvent with the penetrant. And so that's where this next step, requiring close monitoring of the emulsifying process. Wash time and emulsifying time are very critical. Several seconds to minutes at the most. But if you leave, especially method B, post-emulsifiable lipophilic, can have wash times that are a matter of a few seconds, or emulsifying times that are a matter of a few seconds. And if you exceed that too much, you're going to overwash. And again, based on the temperature of water, you're going to use similar temperature of water, that 50 to 100 degree water that you would have used for method A. And then based on the part, the surface finish, geometry, that kind of thing, you're going to have to, you want to get a thorough enough washing to remove any extra penetrant that's left on the surface, but you don't want to overdo it where you remove penetrant from any relevant indications you're looking for. So just a little more detail, the lipophilic was our earliest form from the 1950s. They were oil-based, but what they tend to do is diffuse into the penetrant. That's where they can break down the penetrant, which means they can get into the flaw and can cause that sensitivity with application time. Method D came out later in the 1970s. So again, nothing brand new, but they've improved these since then. But it has a greater affinity for water, being hydrophilic. And so it doesn't diffuse in the penetrant. So it's less likely to kind of pull itself or work its way down into the cracks and that kind of thing. So it's better at helping to remove the penetrant from the surface without pulling it out of the cracks and crevices. So that makes it more sensitive, you get better detection, and it's less sensitive to the removal time. But again, that same final wash with 50 to 100 degree water. And then in both cases of these, both method B and D, if you're using a dry powder developer, you're going to need to place the part in an oven for a period of time just to dry off the surface. That last method that we looked at, solvent removable. So this is, we got to keep in mind, solvent is very aggressive. So when we use a solvent removable penetrant, we've put it on the part and we've allowed it to dwell and hopefully work its way down into cracks and crevices. We want to make sure we don't dissolve the penetrant out of those cracks and crevices. So when we use solvent remover, we don't actually spray it onto the part during the wash step. Okay. Now, when we're all done, if we're trying to clean a part or if we want to pre-clean a part, the remover, the solvent that we use for this is actually a great chemical to pre-clean or post-clean when we're all done. However, it's too aggressive to be applied directly when we're performing our inspections. So with method C, you're going to use your penetrant. You're going to apply it. You're going to allow the penetrant to dwell, again, 10 minutes, 20 minutes, somewhere there. But then the majority of the excess penetrant that's on the surface, we're going to want to remove by wiping with dry paper towels or the white paper wipes that we have in the lab. So you'll use those to remove the majority of that excess penetrant. And then the final step is to take one of those and damp the cloth with the solvent. So spray the solvent onto the cloth rather than on the part, and then use that cloth that's been saturated or has the solvent on it to then wipe the part. And one of the things to keep in mind here, and it's often recommended, is when you're doing this wiping, when you're wiping off the part, is you want to only go in a single direction. So what I mean by that is if, let's see, let me do my pen here. If we have a part here and we're going to wipe it off, what I would do with my highlighter is I would go left to right, left to right, left to right. In this case, I'm right-handed, so usually, and I would do single passes from left to right to do this. You don't want to be sitting here going back and forth, okay? But rather single pass, single pass, single pass. And that way you're less likely to over clean it, as well as to smudge around or kind of smudge out the penetrant that's down in a crack or a crevice. So our process here, that was our liquid-based ones. When we're doing aerosol penetrants, we want to lightly spray, completely covering the area of interest. So this one is kind of like an aggressive spray painting. You want to have enough on the surface that it's fully coated, and that it's, anywhere that there might be a crack, crevice, or anything like that, the penetrant can pull into it. However, if you overspray it, if you put too much penetrant on, it's not going to necessarily hurt anything. It's just going to, one, it's wasteful, and two, it's going to make your job of removing the excess penetrant that much harder. right? So you got to clean all this stuff. So spray it on lightly. You want to fully cover the part, but not saturate it so much that it's going to be a big mess to clean up. And allow it to dwell for that 10 to 30 minutes. And sometimes that's that dwell time is typically going to be specified in a procedure. So if you look up the NDT manual for a part or an aircraft or a component, it'll specify that. However, in lab, I don't specify these. You kind of can pick a time. So if you want to leave it 10 minutes or 15 minutes or 30 minutes, that's fine. Most people find that in our case, for what we're doing, 10 minutes is sufficient. With the aerosol penetrants, remove the excess using a clean dry cloth. And then this is where we use the solvent-based cleaners, then get a damp cloth, get a cloth and damp it with cleaner, with the solvent cleaner, and wipe gently. And again, never spray the cleaner directly onto the part between penetrant application and developer application. We don't want to clean it out. When we're applying our developers, the dry powder, as I mentioned earlier, is a carrier. And that leaves like a film, or it leaves behind the developer that is on each particle of the powder. So the part must be dry so that it doesn't stick or clump. And then you can dust, blow, or dip the part. So you can actually dip the part down in. The powder is very light and fluffy. But other options are to dust it on with something like a paintbrush. Or you can use the little puffer ball type things. If you've ever seen one of those, they're a little rubber ball, almost like a turkey baster. But just remember, with any of these, it can easily become airborne, and you don't want to breathe it. And then you want to make sure that you kind of shake the part, turn it over. You can even tap it lightly to make sure that all the powder falls off after coating the entire part. Because again, you're leaving behind the developer that's on each little bit of powder. For your other types, water soluble or water suspendable, your test piece doesn't have to be dry. You just dip it in, and then you just want to shake off any excess water. If you're using non-aqueous solvent, that's supplied in an aerosol can, or you can use an atomizing spray. But you want to use thin. This is non-aqueous solvent. Remember, this is the portable aerosol spray type developer. It's going to leave a coating on the part. You won't be able to see it right away. When you first spray it on, it's going to be kind of clear, but it's going to leave behind the developer, and then it'll dry to a white film. And this is sprayed kind of like when you're painting. When you've learned to paint, you start spraying on one side of the part. You bring your hand or your spray across, and then stop spraying once you get past the part. So you never want to be pushing the trigger to start or releasing the trigger to stop while the nozzle is pointed at the part. You want to start off to one side and come across. And you want to do a couple light passes. 1 to 2 light passes in a given area is really all you need. If you go too thick with non-aqueous solvent developer, it can actually hide the indication. It can create such a thick layer of developer that the penetrant isn't able to bleed through it. The inspection then takes place. It's a detailed visual inspection. You can using either black light or sufficient white light to be able to perform the inspection. And so these are aided. You can be, in some cases, aided by a magnifying glass. For type 2, you can use a flashlight, or we have the black light flashlights that you can use for type 1. Sometimes you need a mirror, or even when we did scopes, I talked about you can buy specialized video scopes nowadays that have, instead of a white light LED at the tip, they have a black light LED to be able to look inside of parts that have had type 1 penetrants applied to them. So we do that black light or white light. I'm going to go ahead and stop there, and next time I'll finish up discussing inspection, but I got a couple things to talk about before I let you go for the day.